Hi everyone, welcome to my channel Design with Rusbe. Continuing with CSWA Practice Problems, today we'll work on question 5.6. The reason I'm skipping question 5.5 is that for some reason the problems that I have doesn't have question 5.5. As you can see, there's question 5.4, which we already covered, and then it's jumping to question 5.6. So I just wanted to mention this in the beginning of the video so you know why I'm skipping question 5.5. Okay, let's focus on question 5.6 now. In this question, unit of measurement is millimeter grams second. Like always, we need to ensure we are using the same unit of measurement as mentioned here. Now, the difficulty for this question is set as hard. This is the first question that I see that the difficulty is hard, and I think the main reason is because we need to deal with different sketches on different planes. Overall, the concept is the same. You need to make a plane, you need to make 2D sketches, and you need to extrude those features, combine them, and then you get the final geometry. But don't worry, we're going to go step by step, and I'm going to show you how to model this part. In this question, we have the 3D model, bottom view, front view, and section A. My preference is to focus on the top part of the front view first, making this circular feature, then focusing on this bottom feature, and finally adding a small details like a cutout here or here. Okay, so with this introduction, let's jump into SolidWorks and start modeling this part. In SolidWorks, first we need to check unit of measurement, and you can see that we have millimeter grams second, which is the correct unit of measurement. Let's just start with a front plane. Click on a sketch, and let's choose front plane. Here, we need two circles. Click on circle command, and then we need 1 and 2. The diameter of the inner circle is 20 millimeter. The diameter of the outer circle is 23 millimeter. Okay, so now we have fully defined geometry. It's time to use extrude bus feature to make it like a 3D model. Click on feature, click on extrude bus, and then here we need to choose the option. The option I'm going to choose here is midplane because I want the front plane to be right in the center of this feature. According to section A, you can see that the overall width of the geometry is 12 millimeters. So I change this number to 12, click on OK, and that's it. Okay, so now we have this feature. If you look at the 3D model, you can see that we need round corners. In order to make those round corners, I'm going to use fillet command. So from feature, let's click on fillet. Okay, so in the fillet command, we have 4 options, and I'm pretty sure that I used this option before. The fourth option is full round fillet. So in this option, basically you're asking SolidWorks to change 3 surfaces to a full round. So for example, here I select the outer surface, then I select the middle one, then I select the inner one, and SolidWorks shows you the preview. This is a full round. Click on OK, and that's it. Let's repeat this process. Click on fillet, and then I select the outer surface, middle one, inner one, and now that's a full round. Click on OK, and that's it. So now we have the first feature made. Hollow cylinder with a full round on both sides. Okay, awesome. Now it's time to go to the next step. The next step is the bottom cylinder. So if you look at the front view, you can see that the bottom surface of the second feature starts 25 millimeter away from the center point of this geometry. So in order to make that geometry, let's make a plane. So let's go to feature, click on reference geometry, and click on plane. Now click on drop down menu, and from the plane that you see here, I'm going to choose top plane. Okay, so this is a top plane. Now all I need is a plane 25 millimeter away from this plane. So here you see 8 millimeter. Let's change that one to 25. Click on OK. So now we have this plane which is 25 millimeter away from the front plane. Sorry, from the top plane. Okay, so now click on a sketch, and then this plane is selected. If you look at section A, you can see that the diameter of the cylinder is equal to the width of the geometry, which is 12 millimeters. So click on circle command, click on the origin, and then this is a circle. Click on the smart dimension and then add dimension. The dimension for this circle should be 12, and now you can see the circle is fully defined. If I rotate it, you can see that the circle is shown on the plane. Next step is to use extrude boss feature. So click on feature, click on extrude boss, and then this is a preview. Of course, because we use mid-plane extrusion before, the first option is mid-plane. Change this one. In this specific case, I want to extrude this circle until it reaches to the body of this feature. So let's choose up to body, or the other option is up to surface, but I prefer to use up to body. Click on it, and now I have to select the body. So simply click this, and that's it. So basically we told SolidWorks that we want to extrude this circle until it reaches to the body, this pink body. So click on OK, and that's it. So this second feature is also made. Next, we want to focus on a cutout inside this feature. If you look at the bottom view, you can see that we need a circle with 8mm diameter. So let's click on a sketch, and select this surface. Click on circle command, and then here I'm going to make a circle. The diameter of the circle should be 8mm. We also need a line with a 3mm length. So I click on line command, and then here I make a line. The length of the line should be 3mm, so I add this dimension, 3mm. Okay, so now we have the contour. Let's click on feature, click on extrude cut, and then here I select the inner contour. Now if you look at section A, you can see that the depth of this cutout should be 10mm. So from this drop down menu, I'm going to change it to blind, and I'm going to change the depth to 10mm. Click on OK, and that's it. So now we have this cutout made. Okay, so next step is to focus on a feature on a front surface of the geometry. In order to make that feature, everything is exactly the same. We need to first have a plane, then make a sketch on a plane, and then extrude it. Now the question is, what's the desired distance between the new plane and our geometry? According to section A, the distance that we need, the starting point of the feature, is 2mm away from the surface of this blue cylinder. However, that's not a good measure because we're talking about the distance to the surface of the cylinder. It's always wise to define that distance to the reference plane. So here in this case, the front plane is a good plane, right? If I'm looking at this, I need a plane parallel to the front plane. I know that the distance between that plane and the edge of the geometry should be 2mm. I also know that the overall width of the geometry is 12mm, which means that this distance from the edge to this plane should be 6mm. That means the overall distance I need from the plane, the new plane, and this front plane should be 6 plus 2mm, which is 8mm. So what I can do, I can click on feature command and then reference geometry, click on plane, and then here, as I mentioned, I'm going to choose front plane, and for the distance, first let's flip the offset. For the distance, I'm going to choose 8mm, 2mm plus 6mm. Also, if you see there's an arrow here, this means that the orientation of the arrow is to the right. That means if I want to make a sketch on it, SolidWorks always rotate the geometry into this direction. But I want to look at this plane from the other direction. It's not a huge problem, but it makes our life much easier. So in order to change the orientation of the plane, you can simply choose flip normal. And now you can see the arrow change. Now it's showing the other way. So it helps me to look at the geometry from left to right. Now click on OK, and that's it. So that's the plane I need. If I'm looking from the top, you can see that this is a plane, 2mm distance to the edge of the geometry according to section A, and 6mm distance to the center of the geometry. If you have doubt or you think that there could be a mistake in this, you can simply click on evaluate, click on measurement tool, and then you can select this new plane. You can also select this body of this cylinder, and now you can see SolidWorks shows you the minimum distance. The distance between the plane we made, that surface of the geometry is 2 mm, which is exactly correct. That's what we need according to section A of the geometry. So we are good to go. Okay, let's cancel this, and that's it. So now we have this plane. It's time to make a sketch on a plane. Click on the sketch, and choose this surface. Okay, let's rotate this to make our life easier. So now we need a circle. Okay, so let's make a circle here. And the diameter of the circle I need, according to front view, should be 9 mm. So I click on the smart dimension, and this is 9 mm. Also, according to section A, the distance between the center point of the circle and a bottom surface of the geometry should be 6 mm. Now you can see that the geometry is not fully defined. If you don't know why, you can simply click on one point like the center point, and you can see that I can move it left and right. That means that the location of the circle in the x-axis is not defined. All I need to do, I can select the center point, hold Control, click on the origin of the geometry, and from the relations I can choose vertical. Now the circle is fully defined. Click on Feature, click on Extrude, and it's exactly the same. We are doing the same process. Up to body is selected, you select the surface of this body, and now you can see that SolidWorks extrude this geometry. Click on OK, and that's it. Okay. Next, we need a small cutout in this geometry. If you look at section A, you can see that we need a 2 mm cutout. The depth should be 2 mm, and according to the front view, the diameter should be 6 mm. So click on a sketch, and choose this surface. Now click on Circle command, and then here I make one circle. The diameter should be 6 mm. So this is 6 mm, and now we have this. We can use Feature and then Extrude Cut. The depth that we need according to section A should be 2 mm. So this is 2 mm, click on OK, and that's it. Okay, so now we have this feature model. If you look at side section, you can see that this is what we want. We have a flat surface, and this cutout is what we just created. Now, you can ask one question here: why I didn't make these two circles at the same time? I had this option to make a 9 mm circle, 6 mm circle, and then extrude both of them until they reach to this surface, to this body. And that's a valid question. That's actually one solution. The only difference, a subtle difference here, is that if you go with that approach, then you end up with having a curved surface, because these two cylinders are gonna interfere with the body of this cylinder, and the result is gonna be a curved surface, not a flat surface like this. If you want to achieve this flat surface, because according to section A, if you look at section A, you can see that that surface is flat in section A. If you want to achieve a flat surface, this is a solution you can have. First, you need to extrude 9 mm, then you need to make this cutout to achieve this flat surface. So I hope this is clear here. Okay, let's go to the next step. We need a hole in this geometry. So click on the sketch, and choose this flat surface. And we need a 3 mm hole. So let's click on Circle command, and then here I make a circle. The diameter should be 3 mm. So this is 3 mm. Now click on Feature, click on Extrude Cut. And then here, for cutting this surface, we want this extrusion, cut extrusion, to be applied up to this surface. So what I can do, from the drop down menu, I can choose up to surface. And then here I select this surface, and you can see the preview. Click on OK, and that's it. So now we made the cutout in this geometry. Okay, I think that's it. We covered every single feature required for this geometry. Now it's time to check the total volume and make sure that this model is correct. Let's go back to the question and check the total volume. In the question, you can see that the total volume is 2344 cubic millimeters. Let's go back to our model and check the total volume. In SolidWorks, in order to find the total volume, you can click on Evaluate tab and then Mass Properties. And here you can see the total volume. The total volume for our model is 2343.4 cubic millimeters. If you round up this number, you're going to get exactly the same answer as shown in the question, which is showing our model is correct and there's no problem with it. Okay, I think that's a wrap for this video. I hope you liked this video. If you have any comments or feedback, please leave comments down below. Thanks again for watching. My name is Ruzbe. Hope to see you again soon in the next videos.